Let's review factoring out a GCF. And then once you've done that, let's also review classifying each of these expressions based on degree and number of terms. I'm going to do the first one with you to remind you what this is like, and then I'm going to have you practice the second two on your own. So for the first one, remember we usually start by taking the two terms and thinking about what's the biggest number that divides into each of them. So 13 and 39 are both divisible by 13. And then don't forget to check your variables. They each have at least a c, and they each have at least a d squared. And then you need to think about what's left. So 13 divided by 13 is 1, so there's nothing there. C divided by c is also 1, but d cubed divided by d squared leaves 1d. 39 c squared d squared if I divide it by the 13c d squared. So 39 divided by 13 is 3. C squared divided by c leaves a c, and d squared divided by d squared would just be 1, so I don't need that. So this is the GCF that we can factor out, and d plus 3c will be what's left. So I have 13cd squared to undistribute or factor out, and d plus 3c is what's left. Then we were asked to go in and classify based on degree and number of terms. So let's review how we calculate degree. When I'm looking at this, if I have 13cd cubed, that's a 1 and a 3. 1 plus 3 is 4. So the degree of this term is 4. And then I've got a c squared and a d squared. The degree of that term is 2 plus 2, or 4. So neither of these are higher or lower than the other. So the degree of this whole polynomial is definitely 4. We know that that's called quartic. We can also see that this has only two terms. So you have a term and then a plus sign and then another term. So this is a binomial because that's the classification based on the number of terms. So when we name this based on degree and number of terms, we call it a quartic binomial. All right, push pause. Try the next two problems that are just like this one, and then when you're ready, push play to be able to check your work against mine. If you need to push pause, now that you can see my work, feel free to do that. Check your work against mine, and then we'll be ready to move on to more factoring practice of factoring by splitting the middle term. Looking at the first problem, the very first thing I notice is 5, right? We have 5x squared and negative 500. So I'm going to start by factoring out the GCF from the two terms of 5, leaving us with x squared minus 100. Now we've been in this situation before where at first we're like, oh good, I'm done, it's a binomial. But then we realize that this binomial has a square in the beginning and just a number at the end. So we could sneak that plus 0x into the middle and see if that enables us to factor any further. So we have x squared plus 0x minus 100. So the puzzle I'm solving is that I want to multiply to get negative 100 and add to get 0. Well, a negative 10 and a positive 10 will do that. So I have 5, and then the big brackets, x squared minus 10x plus 10x minus 100. So I can turn this into a sum of binomials and look to factor GCFs out of each pair. So x squared minus 10x, those both contain an x and need an x and a negative 10 to complete them. So I have 5 in the big bracket. I factor out an x and I'm left with x minus 10. Then I have a 10x and a negative 100. Those both contain a 10 and need an x and a negative 10 to complete them. So we're going to factor out a positive 10 and we're going to leave an x minus 10. So our final factorization is 5 times x minus 10, because they have that binomial in common, times x plus 10. And that's our factorization. Now, I want to hold on just a minute before we go to the next problem, and I want to mention something that's a vocab word we've never mentioned before called difference of squares. This isn't super important in Algebra 1, but it is super important when you get to Algebra 2. So I want to plant the seed now So when you get to Algebra 2 and they start talking about this, you will have heard it before. I want you to notice something that's happened a few times now. So we had this x squared minus 100. And when we factored it, it became x minus 10 and x plus 10. And if you remember back to some of the other times that we've had something like this, I believe we've actually factored x squared minus 4 on two separate sheets. And both times it factors into x minus 2 and x plus 2. And if my memory serves me right, I think we might also have done an x squared minus 36 at one point, and it factored in to an x minus 6 and an x plus 6. And these were all situations where we add in that 0x in the middle. So there's actually a pattern happening here. If you notice these three examples, it's always x squared as your first number, and your last number is always a perfect square, right? 100's a perfect square, 4's a perfect square, 36 is a perfect square. Remember, we studied all those perfect squares when we were learning to take square roots of things in the radicals unit. So if I have a square, like a square variable, minus a perfect square number, it always factors in the same pattern. So we usually show this pattern this way: a squared minus b squared. So a square minus another square. It always factors according to the pattern you see up here. See how it's always x minus a number and then x plus the same number? Well, that means we factor into a minus b times a plus b. This is not a pattern you have to memorize, but I wouldn't be very responsible if I didn't at least mention it now that we've seen it a bunch of times, because it is a pattern that you will use quite a bit in Algebra 2. All right, let's do a little bit more work. Taking a look at this next one, this one is just a traditional trinomial where you split the middle term. So I'm going to get you started on the pattern, and then you're going to finish it as your homework tonight. So I want two numbers that multiply to make 36 and add to make negative 13. Remember that 36 is coming from multiplying these two sixes together, and then the negative 13 is the middle term. So please make sure that that problem is one of your homework problems tonight. This one down here is also going to be one of your homework problems tonight. The only hint I'm going to give you on this one is to remember that t squared is really 1t squared. All right, we're going to do the problem on the lower left, and that'll be the end of our video today. But I want you to give this one a try, because I'm pretty confident after all this factoring practice you've been doing, you can probably do this one. So push pause and give it a try, and then push play when you're ready to see my work to compare our answers. All right, take a moment and check your work. Finish up the two problems that we start on this sheet. Those are your daily practice for tonight. Make sure that when you finish them, you post your work in the Google Classroom to get credit for today.